All right, so today we're going to move on and talk about sine and cosine graphs, graphing the sine and cosine functions. And it's what we're basically going to do is go from the unit circle, which is a graph, in and of itself, right? It's got coordinates and x and y axis and all that kind of stuff, but it graphs sine and cosine together. And for each angle measure, each special angle, right? We're going to separate out sine and cosine and create their own graphs. And when we do that, when we don't put them together, when we do that, we get an interesting kind of shape out of it. So that's our deal for today. So to get into what a sine and cosine function looks like. So here's your function. Y equals sine x. Remember, a function relates to variables, right? Relates to unknowns. So x, which right here is in the place of where the angle measure usually goes for sine, and y, which is right here. So we're going to relate x to y. X is an angle measure, and y is the value of the sine function at that angle measure. Well, as in anything else that you come across, any function that you don't know how to graph, you've never seen the graph of or whatever, then the easiest thing to do is just to jump right into a t-chart, right? Come up with some values of x, and here, since x is an angle measure, come up with some angle measures that would be pretty easy to find out what that value is so that we can pair it up with this y, right? So in other words, I know from knowing the unit circle that if I put 0 in for x here, that means that I'm looking at the sine of 0, right? 0 radians. We're thinking about 0 radians. Remember, 0 is on the positive x-axis. It's like we haven't moved in the circle yet. So to find sine of 0, just remember that the y-coordinate on that positive x-axis was 0. So sine of 0 is 0. So since the value of sine at 0 is 0, then y is 0. It's a lot of zeros. But that's the idea, right? So, okay, I now have created a point that I can go plot. Now, if you think about the unit circle, the next angle measure that we would want to put in for x that we can easily find the sine of would be pi over 6, right? So sine pi over 6. And the value of sine of pi over 6 is 1/2, and that would be easy enough to graph. We would just have to take these guys as coordinates, right? Pi over 6 is x, and 1/2 is y. And that would be easy enough. But if we keep going around the circle and try to do pi over 4, then we have to try to find a way to graph on the y-axis radical 2 over 2, which is some crazy decimal, and it's kind of tough to graph. So as an ordered pair itself, that would be hard to graph. So we kind of end up skipping those specials, pi over 6, pi over 4, and pi over 3, because they can potentially give us some weird values to have to go graph. So we kind of stick with the quadranals and just come up with an ordered pair for the quadranals. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0 again. And here we've created a bunch of ordered pairs. This is what you would do in any function that you didn't know how to graph or what it looked like, right? Come up with a bunch of points, a bunch of ordered pairs, and just plot them. Now, the next weird part here is that look at how the x-axis is going to have to be labeled. It's going to have to be labeled with radians. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, which we don't typically label the x-axis in a graph that way. But that's okay. We can do it. We can just create tick marks for each of those different values.
Joy, please come to the
Sorry about that. So now that we have our ordered pairs, we need to plot 0, 0. Then plot pi over 2, 1. Then plot pi, 0. then plot 3 pi over 2 negative 1, and then plot 2 pi comma 0. So we can make the tick marks whatever we, on the x-axis whatever we want. We can make the tick marks on the y-axis whatever we want also. So we kind of create those tick marks to make it easy to come up with a graph. And so there it is. So we would connect these dots. Now, as you look, we end up getting this curve, right? They're not straight lines, right? We don't just go boom, 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 and boom and angle them off. It's not how that works, right? And some of that comes from looking at the unit circle. So it's kind of curved. It's a curve. And so you get what's called a sine wave. This is a sine wave, right? And that window right there represents one cycle. That's one trip around the unit circle. So the graph doesn't stop and start there, right? But that's just, what we call a cycle. We could actually let this graph continue down here and let this graph continue up here. And the reason why we know we can do that is because I can find the sine of negative pi over 2. Remember that a negative angle measure means we go clockwise. Sine of negative pi over 2 puts you down on that negative y-axis. And so the sine down there is negative 1. So the wave continues. And if we were to, make this window bigger, you would see this wave go up and down forever. And so that is your sine wave. Okay, that's what it looks like. Amplitude, period, domain, and range we'll come back to in just a second. Okay, now let's see what happens when we put a 3 in front of sine of x. Sine, cosine, tangent, all of those trig ratios can have coefficients just like everything else can. So if we put a 3 in front of the sine x, that means we're going to take 3 times the value of sine of x, whatever angle measure we put in. So for example, sine of 0 again is 0. Then we're going to multiply by 3 to get this value. When multiply 0 times 3, you get 0. Sine of pi over 2 is 1, right? Then multiply by 3 and you get 3. Then sine of pi is 0. Multiply it by 3, you get 0. Sine 3 pi over 2 is negative 1. Multiply by 3, you get negative 3. And then sine of 2 pi is 0. Multiply by 3, and you get 0. Right? So now these become our ordered pairs. So 0, comma 0, pi over 2, comma 3, pi, comma 0, 3 pi over 2, comma negative 3, 2 pi, comma 0. And so again, this is going to be a curve, what's called a sine wave. Okay? And again, since I know that the curve continues on, we can kind of bring these up. Okay? So, what happened? The curve kind of got, taller, right? It stretched up a little bit. So, multiplying by 3 just kind of stretched the graph, the curve up a little bit. Now, amplitude, period, domain, and range. Let's talk about those. Those are the 4 properties that we're going to want to be able to pick out for a sine and cosine graph. The amplitude, by definition, is half of the difference of the maximum and minimum of the graph. Well, another way to say this is the height of a curve. From the x-axis, right? So we go back to the original graph. So the definition says half of the distance from the minimum, which is here, to the maximum, which is there, the lowest and the highest point. Well, that distance, that is 2. Go negative 1 to 1 is 2, right? Negative 1 to 1 is 2, and then take half of it and you get 1. But I think an easier way to look at it is it's this distance from the x-axis to the highest point, right? That's how high the curve goes. That distance is still going to get you 1, right? So the amplitude is going to be 1. And since it's a distance or a height, it's always going to be positive, okay? The next property is the period. The period is the horizontal length of each cycle, right? Each cycle is, I don't want to say it's not your getting to 2 pi, because it's not always going to get to 2 pi, right? It is, the one cycle, it's kind of hard to say, but the one cycle is this right here. And so it was, for a sine graph, 1 up and down, right? And then back to the x-axis. So it's however long it takes to create that up and down for the sine. Okay? That's your period. The domain is the set of all the x values. Everything that I can possibly put into the function. To come up with the domain, sometimes it's helpful to think about what we can't put into the function, but we'll talk about that. And then the range is the same as it has been since Algebra 1, but it's the set of all y values. What could we possibly get as the value from our sine function? So let's go back to our first graph. The amplitude is 1, the period. So it's how long it takes our sine graph to start at the x-axis, go up, down, and come back to the x-axis. And from 0 to 2 pi is how long that took, and so our period is 2 pi. Domain. What can I possibly put in for x? Or if you look at the graph, what x values are we going to actually hit? And since the curve keeps going up and down, up and down, up and down forever in both directions, that means that we're going to end up going from negative infinity to positive infinity. Okay? We can put in whatever angle measure we want for x, and it's not going to hurt our sine at all. Okay? The range is the y-axis, right? So up and down. Where does this graph go up and down? Well, it goes from negative 1 to 1. It stays in between negative 1 and 1, so that becomes our range. Okay? This next graph, same deal. Amplitude. Distance from the x-axis to a peak, and that's 3. Period. It starts here on the x-axis, and it goes up and then down, and then comes back up to the x-axis right there, so our period is 2 pi. The domain, again, we can go as far as we want, left and right, putting in angle measures, so it's negative infinity to positive infinity. Our range, it goes up and down between negative 3 and 3. Okay, so that's how those 4 characteristics work. Now, let's see a cosine graph. Right, so the same idea. Don't know what this graph is going to look like, so let's just find some values that are easy enough to plug in for x, come up with some points, come up with a coordinate for y, come up with some points and plot them. So cosine of 0. Well, cosine of 0 is 1. Then we can use pi over 2. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then we're back to cosine of 2 pi, which is positive 1. So now we've created our points that we want to go plot. 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. This represents a cycle for cosine. If you notice, a cycle for cosine graph is a little bit different than sine graph. It starts at 1 on the y-axis, there at 0. Then it dips down to -1 and comes back up to 1. So for a cosine graph, it's the cycle is how long does it take for the graph to dip down and come back up to its original height. So it's a little bit different than sine. Sine starts at 0. So the cycle for sine is to go from 0 up to 1, back down to -1, and then come back to 0. For cosine, it starts at 1. It goes down to -1 and comes back up to 1. So that becomes its cycle. Now, just like cosine, this does continue on. Okay? But that's its cycle. So amplitude means the same thing. From its highest peak to the x-axis, what's that distance? And that's right here, which is 1. Its period still is 2 pi. It takes 2 pi to make that one cycle I was just talking about. The domain, the x values, we can go left and right forever, so we can put in any angle measure we want, and it means our domain is negative infinity to positive infinity. And our range, cosine graph jumps from -1 to 1. That's the y-axis. Okay? And let's take a look and see what happens to cosine when we multiply by 3, right? So cosine of 0 is 1. 1 times 3 is 3. Cosine of pi over 2 is 0. 3 times 0 is 0. Cosine pi is -1. -1 times 3 is -3. Cosine 3 pi over 2 is 0. Multiply that by 3 and you get 0. Cosine 2 pi, again, is 1. Multiply by 3 and you get 3. So there are points, and we go plot those. And you're going to find out that the same thing happens. It kind of stretches this graph out, at least vertically. Just makes it a little bit taller. And of course, we'd come back down to here. This would keep going here. Our amplitude now the height of our single curve is 3. We're still at a 2 pi period because that's how long it takes to go from being at a peak, going down to a valley, and then coming back up to a peak again. That's the deal with cosine. Domain, again, is negative infinity to positive infinity because we can put any angle measure we want to in for x. And now we're bouncing between -3 and 3 on the y-axis. So that's what we want to use for our range. Okay? The next graph for us to take a look at. What happens if our coefficient is negative? Well, we could go all the way back. So what that means is we're going to plug in the same angle measures that we did for the first graph and then multiply by a negative. So we could go all the way back to our first graph. Oops, too far. And take all of our y-coordinates and multiply by -1. That's what's going to end up happening. It might be too much of a jump, so let's just take a look. So sine of 0 is 0. 0 times -1 is still 0. Sine of pi over 2 is 1. Multiply by -1, you get -1. Sine of pi is 0. 0 times -1 is 0. Sine of 3 pi over 2 is -1. -1 times -1 is +1. So we're kind of flipping everything over. Right? So again, we plot those points, 0, 0. Pi over 2 now is with -1. Pi goes with 0. 3 pi over 2 is +1. And then we're back down here to 0. And so, as you see, the cycle is still the same length, 0 to 2 pi. So our period is still 2 pi. Our amplitude is still 1 because that's the distance of our highest peak or our lowest valley. Could be another way to look at it. Okay? Now this graph again does continue. Our domain is unchanged. We're still going to go left and right forever. We can still put whatever angle measure we want to for x. Our range, is still from -1 to 1. We always go left to right and then bottom to top for our domain and our range when we write them out in this fashion. Okay, so what happened? It just kind of turned the graph over around the x-axis, right? We just kind of flipped it over the x-axis. That's what happened when that was negative, which should make sense. Every time we got a function and we have a negative coefficient to our to whatever our function is, it's always flipped things over, right? Parabolas went from opening up to opening down when the coefficient, when a, if you remember a, was negative, however you want to look at it. Absolute value graphs, the same way, they flipped over. And even linear graphs, positive slopes are up to the right, negative slopes are down to the right, so it just kind of flips it over. So hopefully not too surprising. If we take a look at negative cosine, so it's the same deal. Cosine 0 is 1, but then we got to multiply it by that negative. So this becomes -1. Right? Cosine of pi over 2 is 0. 0 times -1 is 0. Cosine of pi is -1. -1 times -1 is +1. This becomes 0, and this becomes -1. So, same thing. It flips it over. And boom, there we go. Okay. Our amplitude is still 1, even though that this graph flipped over also. Instead of starting at 1, it starts at -1. The period is 2 pi, because that's how long it takes to go through a cycle. The domain is still -infinity to +infinity, because we can still put whatever angle measure we want in there. And the range is still going to go from -1 to 1. That's what it bounces between. Okay? So just getting a sense of what these graphs look like. Okay? Nice little meme here for you. Life is like a sine graph. It has its ups and downs. Oh, how true. Right? But anyway, we can move on. All right, so knowing what we know about how these graphs look, try to take these 8 functions and match them to the graphs below. Stop the video and see if you can't figure it out, and then start it back up, and we'll walk through them. All right, so number 1 goes with graph D, right? If you look at D, the amplitude is 1, so it goes up to 1 tick mark. It's a sine graph. Sine starts at 0, and it's positive, so it's going to go up first before it goes down, right? Cosine, number 2, y equals cosine of x. So cosine of x, we're looking for a graph that starts at 1, then goes down to -1 and comes back up. That graph looks to be, where is it? There it is. A. Starts at 1, then dips down and comes back up. Number 3, 4 times sine of x. Now we're looking for a graph that has an amplitude of 4, but also starts at 0. And that guy looks to be F, right? Starts at 0, jumps up to 1, 2, 3, 4 before it comes back down. Now, number 4 is a typo. This 4 should have been out front for this cosine. Hopefully, you were able to kind of figure that out, and that's going to get you to graph H, because it starts up at 4. Cosine starts up, and then dips down and comes back up. Next one is a sine graph, so it's going to start at 0, but then it's -2. So we're looking for a graph that starts at 0 and then comes down first, and that's E. Comes down to -2 and then comes back up. Y equals -2 cosine of x, right? That looks like it's graph B. It starts down at -2 because cosine starts off of 0. So it starts at -2. and then goes up and comes back down. It's flipped, right? It goes up and then down, not down and then up. 1/2 sine x. So now we're looking for a graph that starts at 0 and only goes up a half, right? And so this is graph C. And last but not least, graph G, which makes sense because it's a cosine graph, so it starts off of 0. It's got to start at a half, whatever the coefficient is, and then goes down and comes back up. Okay? All right. Now, take a quick shot at graphing the next one here. Stop the video. You can start it back up and check your work. Is this what you got? I hope so. If not, if you're not sure where that comes from, then come in and get some help, right? But if you got it and you're ready, try this last guy. Again, stop the video, graph it out, and then check your work. And your graph should look something like that. Okay, just making some quick sketches. All right. All right, so try these homeworks out in Canvas. There is a way to use your graphing calculator to help you check your work. So make sure you come find me and we'll talk through how to do that. There's also a website called desmos.com that we can walk through as well, right? But try your homework and we'll go over questions next time.